Hi, I'm Nigel Griffiths. I work in IBM Power Systems ATS in Europe. In this shared storage pool movie, we'll be looking in particular at thin provisioning, monitoring the free pool space, and then alerting if that space gets a bit low. When we allocate space in a shared storage pool, by default it's thin provisioning. So when we use the make backing device from storage pool command, give it the cluster name and the storage pool, then we give it the 16 gigabyte size. The -BD is just a name that we can use to remember what's in it, and the V adapter connects it to the right virtual machine client. Now that 16 gigabytes isn't actually allocated at that point. It's saying this logical disk unit can go up to 16 gigabytes of space because we only allocate the disk blocks when they're actually written to by the virtual machine client. Now these disk blocks aren't in like little sectors or the regular 4K disk blocks that we think of with AIX. These disk blocks are actually more like 64 megabyte chunks of disk. It just saves a lot of time allocating and managing lots of tiny little pieces of disk. Now optionally we can request thick provisioning or full provisioning. We just put the -thick at the end of the command, in which case all the blocks are allocated immediately. So I have a little logical concept diagram in here. Here we have a logical disk unit. It only has 10 of these blocks, perhaps they're 64 megabytes in size. Perhaps this is a copy of AIX. At the top or the front of our logical disk we've allocated space for slash and slash etc and slash user file systems. Perhaps the slash home was at allocated blocks further down the disk, so that's gone into block 7. And of course we don't allocate the ones that haven't been written to, so they're not actually there. We just have them earmarked so that we could put some data there if we wanted. Now if the logical partition then does a write, and it perhaps creating a file system or logical volume down here in block 5, it tries to do the write, but the block isn't actually there, so the shared storage pool has to quickly allocate a block from the free pool list, puts it there. It can then complete the write operation that it's doing on behalf of the virtual machine client, because the data is actually there now, and then it can return back to the data that that write is completed, and the client is completely unaware of the fact that the block had to be actually placed there before the I/O could complete. Now I ran a little experiment installing AIX7 into a new virtual machine. We allocated the space of 16 gigabytes, not actually there, that's more like the maximum. Then when we did the install, the installer could see that there's one HDisk0 of 16 gigabytes of size. It can't tell what's happening at the back end in the VIOS server. It just looks like a virtual SCSI disk. When we actually finished installing AIX and brought it up, it was convinced that it had used 5 gigabytes, as we can see in the middle there at the bottom, and it was convinced that there was 11 gigabytes of free space. When we actually go and look at the amount of free space that has been used while we did this installation, we find only 3 gigabytes of space has been allocated. The size of the free list has gone down by that much. This means that there's a slight difference there between AIX thinks it's used 5 gigabytes but it actually only used 3. But of course AIX is doing things like allocating paging space. Is only just booted, so it hasn't actually used the paging space, so it hasn't written to it, so it actually hasn't been allocated yet. Also we have file systems with lots of free space in there. AIX has said I've dedicated the disk space to it, but it hasn't actually written to it. And we also have this concept of sparse files that may have holes in it. That could explain for some more space as well. So it's good to know that a new copy of AIX7 is actually only writing to about 3 gigabytes of disk space when it's actually just got installed. Now this is an interesting point in here, the first time I've really come across and thought through thin provisioning. It means that instead of having this 11 gigabytes in this very small case free per AIX, maybe it's actually per file system in the actual machine or per disk. If we add up for lots and lots of virtual machines, maybe we've got 200 virtual machines each with tens of gigabytes of unallocated space ready to use if necessary. If we actually add that up, that's a lot of disk space. We've got tens of terabytes of disk space allocated to all our virtual machines. By pooling them together, by using the shared storage pool, we can actually make use of that spare space and allocate it to the actual logical partitions that really need the disk space, rather than having little bits of reserve spread out across the entire estate. So thin provisioning so good, why do we still want thick provisioning? Well, there's a little problem with thin provisioning that if you're running and you write to a disk and there's no free entries in the pool, then there's not much we can do. All we can do at that point is return disk errors back to the virtual machine. If you want to avoid that problem, perhaps you have important work or production workload, particularly things like databases will not be very happy about unexpected disk errors. Or perhaps you want to create 15 terabytes of disk space and you're immediately going to fill it up. Well, you might as well allocate it now rather than doing it on the fly as you write the various disk blocks. So let's investigate the pool size from my VIOS server here, part of my cluster called Galaxy. At the top here, just a reminder, we have to be at least 2213 level of virtual I/O server to get this running. I still get lots of questions on that via email. These are my logical units that I've allocated to my various virtual machine clients. And then if we miss out the storage pool details, we get a summary of the storage pool Atlantic in here. The size of it, so the adding up all the LUNs involved here is 52 gigabytes, fairly small. I'm waiting for my new disk to arrive. And with the free space is 29, so we actually got plenty of space in there. I'm just trying to do the maths in my head. That's we've used 40% or something, haven't we? If the add up all these gigabytes up here, and this allocated 65 gigabytes, and I've only got 52 in the pool, so I'm actually overcommitted, and I don't know, maybe there's at 15 or 20%. I get a little bit fed up actually trying to do all this maths in my head to try and remember am I in a good position or not. How much of my pool have I used, and how much am I overcommitted, and how close am I to the edge of running into problems. So I actually run a little script here, ls pool, that actually outputs this in a slightly more friendly format. So I've got 54% free at the moment. I've only used 45%, so there's a little rounding error there. Then we have 65 actually been allocated, and so am I overcommitted? Yes, I'm overcommitted by 12 gigabytes at the moment. I got a threshold. We'll look at thresholds in a second. I'm 54% free at the moment. I'm very happy. I have no problems. If this 54% gets up to or gets down to just a few percent, then I really have to take some actions to make sure I don't run out of pool space. I'll explain that you can get the script from the Expert blog at the end of the movie. Because of the problems if we actually run out of free space, it's very important that we track the free space and get warnings when we're getting low. Fortunately, we have a mechanism to do that in shared storage pools. We have the alert command, and as you might expect, it sets a threshold, and we can then get alerts when we hit that threshold. Now, if you look at the manual pages, it just talks about thresholds and doesn't tell you what it actually means. But the threshold is the free pool space getting low percentage alert is what we're going to set. You set that on a cluster and a actual pool, and the value then is the percentage. If the free pool goes below that percentage, then we'll get alerts raised. We can also use the alert minus list command to actually have a look at the current setting. The default I think is 35, which seems a bit big to me, but it's a nice safe number, I guess. And we can remove the alert if we want. That just means it's set to 0, so that it will never actually happen because we can't get below 0. When the free list gets too low and we hit the threshold, we get an alert raised. It can happen on any one of the VIO servers in the cluster, not necessarily the one with the VM that actually allocated the extra space and produced the low free list. So that can catch you out. The next thing you need to know is that the error report command in AIX is actually erlog, as in the admin user on the virtual I/O server, and you're looking for a resource name of VIO dpool and a description of information message. It's not very friendly. It doesn't actually tell you what's going on. If you find one of those, then you can use the erlog -ls command to actually find the details, and I've got an example of that in a minute. So let's actually go looking for one of my VIOS servers reporting this problem. I've deliberately managed to hit the threshold by making the threshold very big, so it's a much higher percentage free. And let's go looking for it in an error log in here. This is the VIOS server that was connected to the client that caused the problem. Okay, now we can see all sorts of events happening here. Oh, I have a transitory error on my disk space in here. We can see some shutdowns and startups as I've switched my cluster on and off, but I don't actually see the problem in here at all. Okay, so let's try the other VIOS server on the same machine. Okay, we can see the discussions about quorums as the various nodes come and go. Oh, we got an informational message down here. Okay, so let's go looking for that in detail. And we'll have to go down quite a way looking for that dpool error. We go backwards one now. Okay, here we go. We've got an alert error here. Dpool in here. So is this the one we're looking for? It says storage pool alert. Galaxy in here. Ah, no, this is just a storage pool up event. This is when I completely switched off the cluster and brought it back. So that's not actually passing a threshold, so that's not the one we want. Okay, let's try another one here in the right command. And we have at the top here, second one down, informational message. Okay, so let's get the detailed version of that. And here it is. So again, this is a dpool event, informational message, asynchronous event occurred. And yes, here's the one we want. It says up here, threshold exceeded. Well, we actually went lower than the threshold, but never mind. This is the one that's actually telling us here this is where we've run out or getting low on free space. That's teaching us one thing, isn't it? That it's not very obvious that we hit this threshold. It's not leaping out at us and telling us that we've got to do something about this right now. So back to my example in here, if we're looking at the summary, we're looking for the VIO dpool informational event. If we then go into the detail one, these are the things we're looking for. We've got an alert event, and we're looking for number 5, the threshold exceeded. That's telling us that we've gone over or under our minimum free size. Now, of course, we want to be somewhat more proactive in being informed that this event has actually happened. One of the things you can actually do is use Systems Director to do that. So I have Systems Director 6.3 running. I just discovered all the VIO servers in the cluster, gained access, and ran inventory. Then I forced myself to go over the threshold, and before I could actually get to Systems Director, it had already spotted this and error, and had actually brought it up in the list of problems. And if you hovered over the entry in here, you can see it has the same output as we have in our erlog command. This happened instantaneously, very quick, and on Systems Director is immediately telling you there's a problem and where it is and what it actually is. Now there's a little bit of bad news in here. To get this working with the initial Phase 2 release, which the VIO server will be 2213, and that's also known as Fix Pack 25, Service Pack 1 and Fix 1, you need a further eFix to get alerts working. Bit of a shame it's got through the testing, but there we go. And I'll put details at the end of the movie that you can get to the AXpert blog, and when that official release is, I'm running it unofficially at the moment, testing it for the developers. When that's officially available, I'll make sure that you know what efix to go looking for or to ask for. So it's very important that we know when the free space is low. So here's some suggestions from me. Systems Director 6.3 works out of the box, so that's pretty good. Other ways of doing things: on every VIO server in the cluster, perhaps you'd want to email yourself once a day what the state of the pool is. If you're doing that, you'd want to use the cron out of the root user, otherwise you can't use the mailx command, but then you can't use the lssp command unless you've included the padmin.profile. So there's an example of how to do that there. Of course, you don't want one every day because people then tend to ignore them. Perhaps number 3 here, have a script that checks the lssp command against the alert minus list command and see if we've gone below the threshold, and then start sending an alert message perhaps once an hour, just to make sure that somebody actually takes an action against that. Alternatively, I know some people take the AX logs and the VIO server logs and they escalate those to some other tool for analysis. In that case, they'll be looking for the VIOD_pool and the threshold exceeded in the text to spot the fact that this is actually a free pool under size. So if your free space is getting too low, what can you actually do about it? Well, the most obvious thing is you can add a new LUN to the pool. Don't forget the no reserve flag. Then you've got some more space, the free pool will be bigger, and off you go again. You could deallocate some space. Perhaps you have an unused logical unit. Perhaps you pre-provision some that you never got around to using it, or you actually have a client virtual machine that you can completely get rid of, including its disk space. Alternatively, we'll look at another movie about snapshots, but if you've got lots of snapshots, deleting the snapshots can actually save you some space. Well, I hope that movie's been useful. Don't forget, if you want the best quality of the movie, you can find those on the tinyurl AIX Movies website, along with 100 other movies about AIX and power and other good stuff. And for the details about that fix and the script that I showed you there, I'll put those on the AIXPert blog. And again, you can see the tinyurl.com/AIXPert.